Hello, once again. We are talking about gut tube and the body cavities. The topic we'll discuss now is formation of the body cavity. This is the second section of the presentation. In this section, we'll be talking about splitting of the lateral plate mesoderm, the primitive body cavity, and the ventral body wall, as well as the vitelline duct. Now let's take up these topics one by one. First of all, we have splitting of the lateral plate mesoderm. So mesoderm, initially it had split into three components. The first component was paraxial mesoderm, which formed somites and somitomeres. The somites and somitomeres arrange in clusters to form muscular elements, skeletal elements, and skin. Then we had intermediate mesoderm. Intermediate mesoderm forms a urogenital system. Now, lastly, we had the lateral plate mesoderm. We are talking about the splitting of the lateral plate mesoderm now. The lateral plate mesoderm forms a visceral portion, a visceral component, which is known as the splanchnic component. It rolls ventrally, again, the ventral surface, the dorsal surface. This is only for explanation. You must have an idea, or you must keep in mind how the embryo is folded and how the folding in embryo proceeds to understand embryology clearly. The visceral or the splanchnic portion rolls ventrally and is closely attached to the gut tube. So now the second part of the lateral plate mesoderm is the parietal or somatic component. It, along with the overlying ectoderm, forms the lateral body wall folds. So now in the figure we can see this is endoderm. Now this is the lateral plate mesoderm, which is now splitting. The upper layer is known as the parietal layer. The lower layer is known as the visceral or the splanchnic layer. Visceral layer is going ventrally and is closely attached to the gut tube. This is the gut tube, and visceral layer is being closely attached to it. Now the parietal layer, it along with the overlying ectoderm forms the lateral body wall folds. Here the lateral body wall folds are being formed. Now these body wall folds, they move ventrally. They're moving ventrally. These are the body wall folds. They are moving ventrally. The space between the parietal and the visceral layer of the primitive body cavity is known as of the lateral plate mesoderm is the primitive body cavity. Now you can clearly see in the figure, this is the parietal layer of the lateral plate mesoderm. This is the visceral layer of the lateral plate mesoderm. In between there is a space which is labeled as embryonic body cavity. So this is how the splitting of the lateral plate mesoderm occurs. Moving on, the lateral plate mesoderm, this lateral plate mesoderm is initially solid. Here you can see it is solid. Now clefts begin to appear. These are the small clefts, which intercellular cavities which appear in the lateral plate mesoderm. These cavities split the lateral plate mesoderm into an upper parietal mesodermal layer. Here it is being labeled parietal mesodermal layer and a lower visceral mesodermal layer. Now you can see, as we were talking in the previous slide, the space between the parietal lateral plate mesodermal layer and the visceral lateral plate mesodermal layer is the intraembryonic body cavity or the primitive body cavity. Parietal layer is adjacent to the overlying ectoderm. This is the overlying ectoderm, and parietal layer is adjacent to it. This is the ectoderm and parietal layer is adjacent to it. It is continuous with the extraembryonic parietal mesoderm over the amnion. Here you can clearly see it. Visceral layer is adjacent to endoderm, which forms the gut tube. Visceral layer is now adjacent to the endoderm, forming this yellow is endoderm. Visceral layer is adjacent to it. This endoderm will form the gut tube in the future. It is continuous with the extraembryonic visceral mesoderm, which is covering the yolk sac. Obvious from the figure. The space between the two layers of the lateral plate mesoderm, again very important. The space between the parietal layer, parietal the upper layer in red, the visceral layer of lateral plate mesoderm, the yellow one, the red one, adjacent to the yellow one. The space between these two is known as the intraembryonic or the primitive body cavity. So now we'll talk of the ventral body wall. This is occurring at the beginning of the 4th week. The sides of the embryo begin to grow ventrally, forming lateral body wall folds. Here you can see the sides of the embryo have started growing ventrally. The lateral body wall folds consist of 3 components. There's parietal layer of the lateral plate mesoderm here in red. Then there is overlying ectoderm, this ectoderm, and cells from the adjacent somites. And the cells from the adjacent somites also form the lateral body wall fold. Here in the figure you can see this is the ectoderm in blue, parietal layer of the lateral plate mesoderm in red. They form the somatopleury, also known as the lateral body wall folds. Okay. Endoderm also folds ventrally along with the lateral body wall folds and closes the gut. Now you can see endoderm is also folding ventrally, and along with these lateral body wall folds, this endoderm is going ventral, and then along with these it also closes the gut. Now the 4th week is beginning to end, and the lateral body wall folds, the lateral body wall folds join in the midline. They are joined in the midline to form the ventral body wall. This is the ventral body wall. Closure of head and tail fold causes the embryo. The closure of head and tail fold causes the embryo to curve into the adult fetal position. Now these concepts are very important. These are occurring side by side and help the embryo to attain the adult embryonic position or the fetal position that is necessary for the growth of the embryo. So now, what is vitelline duct? So the ventral body wall does not close in the region of the connecting stalk. Connecting stalk is this region from where the growth and nutrients are coming to the fetus. In this region, the ventral body wall is not closed. The closure of gut tube is complete except for a small connection between midgut and yolk sac. Between 6th to 10th week of development, starting at 6th week, there's a connection between the yolk sac and the midgut. Here, the connection between the yolk sac and the midgut. From this, intestinal contents herniate into the yolk sac or the amniotic cavity. This is because there is not enough room within the midgut to accommodate all of those. After 10th week, this physiological herniation is repaired. Not repaired in the sense, but this physiological herniation is taken back and all the gut loops are taken within the gut cavity itself. Now, this forms the vitelline duct or the yolk sac duct. This forms the vitelline duct or the yolk sac duct. The duct is incorporated into the umbilical cord eventually. Obviously, it is incorporated in this is the vitelline duct, which is also known as omphalomesenteric duct. It is incorporated within the umbilical cord. Umbilical cord also has allantois umbilical vein and umbilical arteries. The vitelline duct degenerates between second to third months of gestation. So this was the section on the development on how the lateral plate mesoderm splits into two further subsections. The two subsections being the parietal layer and the visceral layer. The parietal layer forms the lateral body wall folds, while the visceral layer helps in the closure of the gut. The space between the parietal and the visceral layer forms the embryonic body cavity. For you to understand, it is very important for you to understand all these developmental processes, because the clinical correlates of these developmental processes are very important and are always or more often than not a part of your clinical exam, your vivas or your talks. For further details, keep watching sqadia.com.